Hello everyone, we are the team electromobility mechanics. Our team consists of leader Ho In-gang and team members Kim Dong-hyun and Kim Hyun-jin. We chose the project theme of ultrasonic positioning device. Now I will explain the overview, principles and structure of the project, showcase the designed circuit diagram and the completed product, and finally discuss feedback and future plans. We anticipate that this technology can be applied to autonomous driving in narrow indoor spaces, such as indoor parking lots, since this technology can determine not only the relative distance between vehicles, but also the absolute coordinates. Its accuracy is very high. Take a look at this picture. GPS transmits microwaves from multiple satellites, and by calculating the time it takes for them to reach the receiver, it can determine the location. Our concept is similar, but instead of microwaves, we use ultrasonic waves. We use the triangulation method. For this, a minimum of 3 transmitters is required. Let's compare 3 cases. In the first case, we can only know the distance between the transmitter and the receiver. In the second case, there are 2 interactions points, so we still cannot determine the precise location. However, in third case, we can finally calculate the coordinates of the receiver. Therefore, we plan to create a total of 5 modules. All modules have the same configuration, with each having ultrasonic transmission and reception capabilities. 3 of them are planned to be transmitters and 2 are receivers. The reason for needing 2 receivers is to demonstrate autonomous driving by installing them on RC cars. This page explains the specific operations. Although it looks complex, it can be summarized in 2 points. One module transmits waves to synchronize the ultrasonic generation cycle, and modules are organically connected. So, to calculate the position of the receiver, of course, you have to know the position of the transmitters. So you might think that these modules are connected like spider webs. However, we only produced 3 modules. I will explain the reasons later. Anyway, we used only 2 transmitters. Let's look at this flat coordinate system. Assume the coordinates of transmitter 1 are the origin and transmitter 2 is on the positive x-axis. As mentioned before, knowing the distance before transmitter 1 and 2 allows us to determine the coordinates of transmitter 2. Now let me explain the circuit diagram. However, I will skip to technical details to align with the presentation's purpose. As you see in the picture, we used PCB as a substrate. This part is responsible for power supply. This is the circuit generating the FPGA clock. We separated this circuit for easier debugging. Then there is the radio transmitting circuit. I told you earlier that we use radio waves for synchronization, but we didn't use the radio receiving circuit. We used a commercial module instead. FPGA drives the modules and generates frequencies for both waves, ultrasonic and radio, and it processes the data so that the MCU can do the computation. The upper part is the Verilog code for programming the FPGA, and the lower part is equivalence code in C language. I will skip detailed explanations. This is the ultrasonic transmission circuit made with transducers. And this is the ultrasonic reception circuit made with a digital microphone. Finally, the MCU circuit. This circuit has a function to input and display the ID, which is the module number. The code programmed into the MCU. The MCU handles core functions such as data transmission and distance calculation. In these slides, we show that both waves and ultrasonic waves are received successfully. The modules we created. One on the left is the receiver and the others are used as transmitters. Arduino is responsible for transmitting data to the PC. Now let's watch the video together. Originally we planned to demonstrate autonomous driving, but due to a change in plans, we switched it to outputting coordinate data to the PC. The reason for the change in plans was that the components were too small, making PCB soldering difficult, and there was not enough time to manufacture the modules. Similarly, due to a lack of time, we did not manufacture the wave reception circuit. And there were a few other issues as well. Initially, we considered using pressure and temperature sensors, considering the impact of air pressure and temperature on the speed of sound, but we omitted them as their influence was minimal. Finally, I will conclude the presentation by showing the final modified circuit diagram. Thank you for watching.